The next week's lecture, we're going to talk about AV blocks, atrioventricular blocks. So last week we talked about enlargement of the atrium, enlargement of the ventricle. We took a look at P waves, we took a look at the QRS, and now we're looking at what happens in the middle of the heart, which is what we call the AV, right? So SA node, AV node, then divides to his bundle. So let's take a look at some of our learning objectives we're going to talk about. In this lecture, we are going to look at what in the heck is a block, right? We can classify them as first degree, second degree, or third degree. We're going to be taking a look at the EKG on all these three different types. I want you to be able to differentiate between the three types of AV blocks, and we're going to be able to do that. We want to know a little bit about what causes them, explain the different treatments, and then what are the clinical implications for having one of these three blocks. So, when we think about conduction, it begins up in the SA node and then it goes down to the AV node. If there's a disturbance or a blockage or a delay or something going on in the communication within the AV node or further down in what we know the bundle of His, it's going to prevent the contraction or the cardiac impulse from getting down to the ventricle, into the bundle branch blocks. That's why we say we can have a first or second degree block or third degree. And just to make your lives a little more confusing, when you get to a second degree, we have two types. We have a type 1 and a type 2, and we'll talk about those in a minute. So let's take a look at the first degree. Probably the easiest is understanding the first degree. It's just simply, I want you to write down, it's a delay. It doesn't say that on my slide, but fundamentally it's just a delay. So we call it sinus rhythm. Remembering what is sinus rhythm back a couple lectures ago, right? A PR interval, the P, the QRS. The thing that's different with the first degree is everything looks like it's supposed to be sinus rhythm. However, the PR interval is longer than it's supposed to be. So that PR interval is greater than 0.2 seconds. Remember I told you we needed to look at the PR interval back in that lecture? This is why. So if we have a PR interval that's bigger than 0.20, you're going to, and nothing else is wrong. The P, the QRS, T, everything looks classic. 1 P wave for every QRS. Heart rate's where it should be. The shape of or the morphology of the P wave is classic. We have what we call a first degree AV block. The thing about a first degree, I say it's easy for me to explain it to you because it's very normal looking. It's very much looks like sinus rhythm with the exception that the PR interval is too long. So if you took a fast look at this tracing on your computer, you might say this is normal sinus rhythm, right? Because it doesn't look like there's a giant irregularity going on, right? The P, the QRS, the T, everything looks very systematic. However, when you do the counting of how long are the waves, you will notice that the end, so you count the boxes from the end of the P to the beginning of the R, right? That PR interval. And if you count the boxes on this slide, we have 0.24 for the PR interval. That is bigger than 0.20. Voila, the answer is a first degree. We call it a first degree block, but in your head, I'd like you to remember it as the word delay because nothing is missing. There's no irregularities. The only problem is the PR interval is delayed. Going down the conduction track, that communication is delayed, therefore it's slowed. So the PR interval on the tracing is longer than it should be, right? A delay communication moving down the AV track is what we call an AV block, a first degree block known as just a delay. What would cause this? Well, lots of little things can cause this. So parasympathetic tone changes, AV node disease, basic heart disease, CAD, someone can be on medication. The thing about the first degree is it's benign, doesn't really require any treatment. Unless it progresses to a higher level, they might investigate a little bit more. In the presence of really slow bradycardia, they could use atropine to elevate. But in the nutshell, when you take a look at this tracing, first degree AV block, everything looks classic. However, at closer evaluation, you notice the PR interval, right? Again, the PR interval is greater, all of them. Each one, each PR interval, every single PR interval on here is greater than 0.20. Okay, so that's easy, right? First degree, think about this as a delay. When we talk about the second degrees, we have two types of second degrees. Okay, so type 1 has different names. This is where it gets confusing. So a second degree can be type 1 or type 2. Type 1 can be called Mobitz Type 1. It also can be called Wenke Bach, which is the man's name who kind of founded or discovered this. So Wenke Bach, Mobitz Type 1, right? Second degree type 1, they're all the same thing, which is confusing because the language just makes this confusing. So when you think about a second degree type 1, I love to use the word Wenke Bach, and you'll see in a minute. But so when we have a Wenke Bach, what happens now is we have a dropped beat. So it's pretty apparent when we look at the EKG. So you have a non-conductive P wave. This is not sinus rhythm. What happens is the PR intervals progressively get longer and longer and longer until a QRS is no longer there. So Wenke Bach means the PR interval is not all the same. Just I showed you in the very last slide with the first degree that all of those PR intervals were the exact same on that picture was 0.24. With a Wenke Bach, the PR intervals vary. The rate is variable with a dropped, a missing beat. So if 3 to 5 beat progressive, kind of they come in all ratios. I'll show you what that means. So this is what we call Wenke Bach. Second degree, type 1 Wenke Bach. So we take a look. The P to the QRS, right? The PR interval looks fine there. It gets a little longer. Oh my gosh, look at how long that is. Way longer than 0.20. Way longer, and then we have a dropped QRS, and then it begins again, right? PR interval slowly gets longer. It gets longer, and then we have a drop, a missing, right? So these PR intervals vary, right? So they get longer at 0.22. They get really long. So that's why I like the word Wenke Bach. It's a really goofy name, and I think the goofy name helps you to remember that it's a variable PR interval. Gets longer and longer and longer, and then you have a missing, then it ends up missing. So second degree type 1, it can be called Mobitz Type 1, it can be called Wenke Bach, it can be triggered by medicines, ischemia, lack of blood flow, enhanced vagal tone, similar kind of things. Like many different things can trigger this. We're not really worried about the causes of a second degree. What I want you to know is that, again, usually the person doesn't know they have this. They usually can't feel it. And again, it's really not something that's usually treated. Now, type 2 is different than type 1. They're both second degrees, right? So second degree can be type 1 or type 2. A type 2 Mobitz, right? Mobitz type 2, second degree Mobitz type 2. This is different. What we see with a second degree Mobitz type 2 is an irregular ventricular rate. It oftentimes is undiagnosed or misdiagnosed, and this can be life-threatening. So this is what it looks like, where you have a PR interval that's always longer than 0.20. Okay, so that kind of sounds like first degree, PR interval greater than 0.20. However, what makes it different from first degree and why is it a second degree Mobitz type 2 is that you end up having a non-conduction. So you're missing the contraction. In the first degree, every wave was bigger than 0.20 with nothing missing, right? It was just simply a delay. There were no missing beats. In second degree Mobitz type 2, every one of these PR intervals is the same distance. They are all longer than 0.20, right? Again, in this example, they're 0.24. The difference why this is not a type 1 is because you have non-conduction happening. You have a dropped. So when you look at Mobitz type 2, second degree, is that again, every PR interval is the same distance, but the difference here is we have a missing wave. So the thing about Mobitz type 2 is intermittent non-conducting P waves However, it's not type 1 because it's not progressive prolongation of the PR interval. Remember I told you type 1, second degree type 1, Wenke Bach, Mobitz type 1, it is variable with progressive prolonged PR intervals. With this second degree type 2, it's not progressively getting longer, but we still do have those intermittent dropped waves. So dropped QRS that causes an irregular RR interval, no conduction. And this is often caused by a heart attack, fibrosis or decondition or disease of the conduction system. It can cause by medicines. Mobitz type 2 is something that oftentimes comes with a low heart rate, hemodynamic instability, which means the person often feels lightheaded, dizzy, syncope. They could lead to sudden cardiac death. The problem with what I just showed you is that second degrees are confusing, right? So the first degree is simply a delay. Everything looks like normal sinus rhythm, except it's not because we have a delayed PR interval, right? That's your first degree. The second degrees are really confusing. I really want you all to pause the lecture right here and open up another YouTube page and watch this video. You will laugh. You will roll your eyes at the song, but this video will hone in on the differences between a Mobitz type 1 and a Mobitz type 2, right? They're both second degrees, right? Mobitz type 1, I like the word Wenke Bach because, again, it's variable, longer, PR interval till it drops, versus Mobitz type 2, the PR interval is always too long with the dropped. So definitely pause and watch this video just so you can laugh a little bit when you come back on, right? The song will get stuck in your head. So here's Wenke Bach, right? So you've got the dropped variable weight, right? Mobitz type 1 Wenke Bach, where it gets long and then it gets longer and then it fails to conduct a wave, right? That's what we call Wenke Bach. With Mobitz type 2, a little different. Again, the PR interval always is the same with a dropped wave. Commonly, the treatment for a second degree Mobitz type 2 is going to be a pacemaker. Okay, so let's go through this. So first degree is characterized by a prolonged delay. The PR interval is greater than 0.20. Every atrial impulse makes it through. It activates the ventricle. The only thing you want to know about your first degree is that there's a slight delay between the SA node moving down to the AV node from the AV node moving down to the ventricle. And what that looks like on the EKG is a PR interval, prolonged, delayed, greater than 0.20, right? That's what you're going to remember. So this PR interval is the same in each of those. We call that a first degree. In our second degree AV block, both second degree AV blocks, there's something missing. How do you tell between Mobitz type 1, Wenke Bach, versus just simply Mobitz type 2? Is the PR interval is variable, it gets longer and longer and longer in Mobitz type 1, Wenke Bach, versus type 2, it's always the same distance, too long, with a dropped wave. So Wenke Bach, right? The YouTube video, the song, as I laugh just thinking about it, helps us to understand that it's progressive lengthening of the PR interval until one wave fails to produce the wave, right? So you just saw this, right? Longer, and then fail to no conduction. With Mobitz type 2, more severe, your type 2, where you still have a prolonged PR interval. It's longer than 0.20, right? So it does not have progressive lengthening. The number, when you count the boxes of the PR interval, it's not getting longer and longer. But now those impulses are not being transmitted to the ventricle, and progressive lengthening is not occurring, and you're having a failed beat. And what you commonly see with someone who's in a type 2, low heart rate, dizziness, syncope, right? They're not feeling good. A lot of times this is going to be a pacemaker. The other one I haven't mentioned is a third degree. Third degrees are something we don't see a lot in cardiac rehab, right? We call this a complete heart block. It's something I don't commonly put on a test because I just think it's You need to know they exist, but recognizing them can sometimes be tricky because sometimes they look like something else is going on. But something I'm not that concerned with in a cardiac rehab setting, because most people by the time they get to a third degree, they just aren't well, right? So now it's a complete heart block where the atrium and the ventricles are completely independently kind of beating to their own drum. You got an atrial contraction up in the atrium, you got the ventricle contracting. They're not communicating together. So the PR intervals are the atrium, the RDR intervals are telling us the ventricle. There's no consistent PR interval. The QRS is usually wide. When you look at this third degree, you're like, ooh, what is going on here? Again, I'm not a big one to test on third degrees because it's something that we just simply don't see. What I want you to know about a third degree is that they're not in good shape, right? So usually have a heart attack. They're usually, their vagal tone is really impaired. It could be changes from medicines. That could be the trigger of the complete heart block. So what have you learned in this short little lecture is that when you're thinking about a block, you're thinking about the PR interval. AV blocks mean your eyes go to the PR interval counting the boxes, right? That's what you know, right? An AV block, count the boxes of the PR interval. Are they greater than 0.20? If they yes, then check the box, yes, I have an AV block. What type of AV block you have depends on, is a wave being blocked, right? That's a second degree. If it is, do you have a Mobitz Type 1 Wenke Bach where the PR interval is getting longer and longer and longer, or do we have a Type 2 where it's consistent with the failure to drop? So taking a look at comparing the differential diagnosis of our AV blocks, and again, you're really focusing primarily on the length of the PR interval. Third degree AV blocks are a little tricky because, again, we don't commonly see them, but the person is usually not feeling that well. You've got the P wave doing its own thing. You've got the ventricle contracting independently on its own, and it's going to cause fluctuating PR intervals, and that's what we call our third degree block. So if the PR intervals are constant, then Mobitz Type 2. If the PR intervals vary, then we're going to call it with a third degree. Mobitz Type 1 versus Mobitz Type 2, what is the difference between these? PR interval progressively increases. If that's the case, you call it Mobitz Type 1. I like to use the word Wenke Bach, which is the same because, again, the goofy name and the goofy rhythm. If the PR intervals are constant, we're going to go with the Mobitz Type 2.